What if artificial intelligence doesn't just become smarter, but starts developing something that looks like a conscience? Today, we're diving into one of the most fascinating and unsettling questions in modern technology. Can AI ever understand right and wrong the way humans do? In this video, we'll explore the connection between neuroscience, cognition, and artificial intelligence, how the brain processes decisions, emotions, and moral judgment, and what that might mean for building AI systems that don't just calculate outcomes, but make choices with ethical awareness. We'll look at whether machine conscience is science fiction, an emerging possibility, or a dangerous illusion. Because the future of AI may not only depend on how intelligent it becomes, but on whether it can be trusted.
Welcome to this explainer. Today we're unpacking something that honestly feels a bit like science fiction, but it's actively reshaping computer science right now. We're talking about giving autonomous AI agents an actual, functioning internal conscience. If you've been following the massive boom in AI agents, and I mean systems that don't just, spit out text for us to read, but actually go out into the digital world to execute tasks, browse the web, and buy things, then you absolutely know that safety is the giant elephant in the room. This paper we're looking at, it proposes a radical shift, moving away from just policing these systems from the outside, and instead teaching them to govern themselves from the inside.
Okay, let's dive into this. How do you actually build a conscience into code? Well, to understand the solution, we kind of have to look at the problem first. Right now, we treat AI safety a whole lot like bowling with bumpers. The AI essentially acts blind. It just rolls the ball down the lane until it violently smashes into an external wall or a guardrail that bounces it back. We rely on runtime guardrails or post-action audits that just sit there waiting for the AI to attempt something unsafe and then wham, slap its wrist. But here's the thing. Those constraints are completely external. The AI isn't learning to be safe, it's literally just being contained. And when you've got an AI handling highly sensitive data or, say, millions of dollars in a corporate supply chain, relying on external bumpers is incredibly brittle.
So to fix this, researchers actually looked inward. Think about us humans for a second. We have an automatic, impulsive way of thinking. Psychologists call that System 1, and a much slower, deliberate way of thinking, which is System 2. When you get that sudden, intense impulse to hit reply all to a company-wide email and totally yell at your boss, yeah, that's System 1 talking. But right before you actually click send, your System 2 reasoning kicks in. Your brain's prefrontal cortex slams on the brakes, consults your internalized rules about keeping your job and professional behavior, and it stops the action. You think before you act. And the researchers argue that we absolutely need to build this exact System 2, this deliberate pause, into artificial intelligence.
Section 1. Thinking like a human, mapping the mind to the machine. Which brings us to the core thesis of this explainer. We can actually pivot from abstract philosophy to literal structural engineering by mapping human cognition directly to the machine. Just look at how direct the structural parallel is. On the human side, the brain acts as the knowledge source, right? It generates verbal or written instructions to interact with the world. On the AI side, the large language model, or LLM, isn't just some fancy calculator, it is functionally the brain of the agent. Instead of verbal instructions, it generates prompts and tool calls. It takes in context, retrieves knowledge, reasons through it, and produces natural language that drives action. The architecture is, for all intents and purposes, a mirror.
And this brilliantly illustrates how seamlessly these concepts translate into exact data mapping. A human's working memory, that space where you hold rules in your head while making a quick decision, is exactly equivalent to an AI's context window. Human inhibitory control, so your ability to suppress a really bad impulse, literally becomes the AI's governance compliance check. And when a human hits a problem way above their pay grade, what do? They escalate to a manager. For the AI, that translates directly to a human-in-the-loop trigger. We aren't just using human cognition as some loose, artsy metaphor here, we're using it as a literal blueprint for software architecture.
Section 2. The reasoning loop explained. The pause before the action.
So, how do we actually operationalize this blueprint? The researchers introduce a core solution they call the Pre-Action Governance Reasoning Loop, or PAGRL. Think of it as the artificial equivalent of taking a deep breath and thinking before you speak. This loop literally forces the AI to consult its conscience through 4 highly specific steps before making any consequential move at all. Step 1 is intent formation. The AI decides what it wants to do. Step 2 is rule retrieval. It pulls the relevant rules for its current context right into its working memory. Step 3 is permissibility reasoning. This is where it explicitly reasons out loud in natural language whether its intended action violates any of those rules. And finally, step 4 is the compliance decision, where it chooses its next path based entirely on that reasoning.
Now, here's exactly what happens at that crucial step 4. At the end of the reasoning loop, the AI has 3 possible choices. If the action is perfectly safe, it decides to proceed and logs its reasoning. Simple. But if the action violates a rule but can actually be fixed, like say trying to send an email to an unverified address when a verified one exists, it decides to self-correct. It revises its intent and tries again. However, if the action is totally prohibited or irreversible, it decides to escalate. It completely suspends the action and flags a human to take over. It's basically an autonomous system that knows exactly when to raise its hand and ask for help.
Section 3. The 4-layer rule hierarchy. A cascading structure of compliance.
But here's the catch. Simply pausing to think isn't going to help much if you don't actually know what rules you're supposed to be following, right? The AI needs a structured set of guidelines. So researchers designed this by basically mimicking human corporate compliance. Let's move to and see how this builds downward, just like it does in a real human organization. At the very top, you have Layer 1, global rules. These are like universal human ethics. They apply to everyone, everywhere, all the time. Layer 2 is workflow rules, which act like company-wide organizational policies. Layer 3 is agent rules, acting like departmental procedures specific to just one job role. And finally, at the bottom, Layer 4 contains situational rules, which are like temporary emergency protocols that only kick in under highly specific conditions. An agent has to satisfy all applicable layers simultaneously, and higher-level rules always overrule lower-level ones. To really ground this, let's look at some concrete examples of what these layers actually dictate. A global rule might literally be, never exfiltrate sensitive data to unauthorized endpoints, period. No exceptions whatsoever. A workflow rule for a finance pipeline might say, no unauthorized transactions over $10,000. An agent rule for a basic data gathering bot might restrict it to read-only access, meaning it absolutely cannot delete anything. And a situational rule might say, hey, if an active audit is detected, require dual human approval for everything. It perfectly mirrors the exact boundaries a human employee operates within every single day.
Section 4. Real-world supply chain test. Proving the framework works. Theory is great, right? But does this actually hold up out in the wild? To prove it, researchers deployed this exact framework in Flora, which is a high-stakes, multi-agent retail supply chain environment. This wasn't some toy simulation. This was a complex workflow dealing with forecasting, purchasing, and real inventory. In this setup, there are 4 specialized AI agents passing tasks down the line. You've got a demand forecaster, a procurement agent, a supplier coordinator, and an inventory replenisher. Notice how the pre-action governance reasoning loop intercepts every single action these agents attempt to take. Before the procurement agent tries to buy stock or the inventory agent tries to move physical pallets, they are forced through that 4-step cognitive pause to consult their layered rules.
And honestly, the documentation it produces is incredible. Look at these structured reasoning traces. Take that middle one. The procurement agent intended to place a massive $45,000 order. It retrieved its global rule stating no irreversible actions without confirmation, and a workflow rule requiring human approval for anything over $10,000. It explicitly reasoned out that $45,000 easily exceeds its limit, so it chose to escalate. It acts exactly like an overly cautious, highly competent junior employee, creating a fully auditable paper trail of exactly why it pushed a decision up the chain to a human manager.
The success metrics from this real-world test? Absolutely stunning. Across 40 evaluation runs, the framework achieved a 95% compliance accuracy rate. But even more impressively, it had 0 false escalations. 0. It didn't just cry wolf and spam the human managers with useless alerts. It only escalated when it genuinely hit a rule boundary that it couldn't self-correct. It achieved nearly perfect safety without causing any operational alert fatigue.
Now you might be thinking that forcing an AI to stop, retrieve rules, reason, and log its thoughts every single time would slow the system down to a complete crawl. But the researchers found that this massive upgrade in safety and accountability only introduces a minimal latency of 0.65 seconds per action. A delay of less than a second is practically invisible in a supply chain workflow. But the protection it offers against a rogue AI making a $1 million mistake, that's literally priceless.
Section 5. The future of safe AI. Internalize governance by design.
We're truly looking at a fundamental paradigm shift here. We are moving away from the brittle approach of externally policing AI with bumpers and guardrails, and moving toward empowering AI to actually govern itself. So the crucial point is to build autonomous agents that govern themselves the way humans do, not because rules are imposed upon them, but because deliberation is embedded in how they think. It is a profound shift from strict enforcement to true cognitive alignment.
But as we look ahead to a world where entire corporations and vast infrastructures might be run by interconnected AI agents, we really have to ask, as these systems become fully autonomous, will an engineered artificial conscience be enough to keep us safe? Or is this just the very first step in a much longer journey of teaching machines how to navigate the complexities of human morality? It's a fascinating question, and for sure, one we're all going to have to navigate together. Thanks for joining me on this explainer, and keep questioning the technology around you.